So we are going to learn a solar cell. Previously we have seen photo devices. So one we have seen photodiode or photodetector, which is going to be operated in this region. And the next thing is the solar cell, which is made to operate in this region. So solar cell or photo device is made to operate in this region such that it will extract this characteristic benefits. Here, this is the normal diode characteristic. This is the normal diode characteristic. Whereas this is the photo device characteristics, that is solar cells characteristic. Here, this region is the converting region. This region is the converting region, and in this region light energy is converted into electrical energy. So this is called solar cell, and that property is utilized in solar cell, which will convert light energy into electric energy. And what is the normal cell? Normal cell is the device which will convert chemical energy into electrical energy. In the same way, light energy will be converted into electrical energy in this region by using this characteristic of the device, VI characteristic of the device. Now, this is the current and this is the voltage. Now we can see the device, and this is the 3D picture of the solar cell. 3D picture of the solar cell, and this is the photo device symbol, photodiode symbol. Here light energy, H nu, energy is given, is supplied by the light, and here always we will represent the current which is flowing in the forward direction, that is arrow mark direction lo unna direction lone current ni represent chestam, and along the direction the potential is dropped here. Vd is the potential, and this is the 3D picture of the solar cell. And what we can observe here is that two layers of the semiconductor device, semiconducting material. This is N type and this is P type. And on the top, this is the metal region. This is the metal region. So this metal, why we need this metal region is to make a contact with the device. That means this device will utilize the light energy and it will convert that light energy into electrical energy. So we have to take that electrical energy. So we need a point from which we can take that electrical energy, and for that purpose these are the metal contacts. And why these metal contacts are broken here, that we have to know. With normal diode, we cannot design the solar cell with normal photodiode. So what we need? We need a special designing or special construction for that purpose. And this is the design. Here the metal contacts are at the back of the device and also on the top of the device. And on the top, this metallic device is slotted. That means it is broken. Why it is broken means through these regions only the light can enter into the device. What we need? We need, after all we are converting light energy into electrical energy. So the light energy should pass into the device. So through which path it will go into the device? Through these regions it will go into the device. And these regions are shown here. and these regions cannot allow the light to penetrate through it because metal will reflect it. But these gaps which are shown here, these gaps will allow the light to pass through the device, and the light will pass through this device, and these gaps are coated with anti-reflection coating. That means whatever light is coming, we are making a facility that all the maximum of that light will enter into the device. Because of this coating, maximum 90% of the light will be captured by this coating and nothing will be reflected back. So maximum amount will come into the device. And here we will make a thin region of N-type semiconductor, a thin region, and somewhat a large region of a P-type semiconductor, and our device is designed like this. Why we have taken a small, a thin region of N-type semiconductor means, we know that already we have seen that our device will effectively work in the depletion region. In the other regions, whatever light is entering in the other regions, that light will make some whole electron pairs, but those whole electron pairs cannot be traveled or cannot cross the depletion region because of the recombination, because no electric field will be formed in these two regions. Only electric field, that is electric force, will be formed in this depletion layer. So whatever light energy working and whatever light energy efficiency is there, whatever light energy will make the whole electron pairs, those whole electron pairs in these regions will not generate the current. After all, what we need? We need this light energy to generate some current. That is nothing but our light energy conversion into electrical energy. So in these regions, whole electron pairs will be formed due to the light energy, but there will not be any driving force to carry the electrons in this direction and holes in this direction. So maximum light has to reach the depletion region. So for that reason this N-type layer is made thin. Chala chinnaga chestam. So whatever light is coming, it will directly touch the depletion layer. Ikkada unde depletion layer ni touch chestadu. Touch cheyadam valla emavutadi? We know already in the previous topics only we learned that whole electron pairs will be formed here due to the light energy. And these whole electron pairs, and we know that this is the N-type material, and my light is the same thing. My light is entering through the N-type region. N-type region lonchi na light enter avutundi. Ikkada first deni hit chestundi light? N-type region. So my light is entering through the N-type region. Ikkada N-type region undi. Ila vachinappudu it will touch the depletion layer. Depletion layer touch chesinappudu em avutadi? So here whole electron pairs will be formed. Already this depletion layer will be filled with immobile positive and negative ions. Ante kada depletion layer lo P type వైపు ఏమో negative ions ఉంటాయి, N type ఏమో positive ions ఉంటాయి. More whole electron pairs will come out. అప్పుడు ఏమవుతుంది? This positive and negative ions will form an electric field whose direction will be from positive to negative. E direction lo electric field direction untadi. So we should remember that electron movement will be always opposite to the direction of electric field. Electric field direction itunte electron direction etundali? Opposite to it. And moreover, this electric field direction will be same as the whole movement. So electrons it push chestadi electric field, holes ni it push chestadi. And always we represent that this is nothing but a reverse current which is flowing and always we will take the current direction as the whole current direction. That means holes are moving from N to P. So my current also will be from N to P. That means here this is the negative and here this is the positive. My current will be from this direction to this direction. That means this is cathode and this is anode. The current flowing ante actual ga local current reverse direction lo untadi, but we will take the current flowing in this direction as the reverse saturation current or reverse current. Aa current ikkada flow avutadi. Andu batti clear e kada. So in this way current will be produced due to the incidence of the light energy on this surface of this device. So this is nothing but a solar cell which will convert light energy into electric energy. And now we will see that how this device will work in this region. Endukani ee region lo work chesetattu మనం డిజైన్ చేసాము. ఈ రీజియన్ లో వర్క్ చేస్తే ఏమవుతుంది, ఎలా మన ఎఫిషియన్సీ, హౌ వీ కెన్ ఐడెంటిఫై ద ఎఫిషియన్సీ ఆఫ్ ద సోలార్ సెల్ అన్న చూద్దాం. బిఫోర్ గోయింగ్ ఇంటూ ద క్యారెక్టరిస్టిక్, నౌ వీఆర్ గోయింగ్ టు లెర్న్ or we are going to develop a equivalent circuit for this solar cell. Solar cell anedi the same photoelectric device or photo device is made to work as solar cell. అంతకు ముందు మనం ఫోటో డిటెక్టర్ని కూడా ఇదే ఫోటో డయోడ్ తోటి డిజైన్ చేసాం. అలాగే ఇప్పుడు ఇదే ఫోటో డయోడ్ తోటి we are going to design the solar cell. But what we are doing is we have seen to and we are making this device to operate in the fourth quadrant lo operate ayyettattu chustunam. Now this is my normal diode. If some light is falling on the diode, then it will become my photodiode. So naturally I will represent the forward current of the diode in this direction, and my voltage, diode voltage, will be between these two terminals. Now suppose I want to make an equivalent of this device. So what I will do, I have to represent this light energy as a element. Okay, element laga చూపించాలి. either a voltage or a current or a diode, ఏదో ఒక దానిలాగా నేను చూపించాలి. So how I can represent this light energy as an element means, by the incidence of this light energy I will get a current which is a reverse current. So what I will do, instead of this light energy I will, and you know that my current will flow from cathode to anode, అంటే ఈ డైరెక్షన్ లో ఉంటుంది నా కరెంట్. This is nothing but my light current. This is nothing but my light current. So this light energy will produce some reverse current, and that current is represented with a source which is IL, current source, and this light energy is represented with this. So a normal diode will be represented with the normal diode. So extra, what we are getting extra is this current, and this is the replacement of this light energy and our effect of this light energy. And so this is nothing but my ID, and this is nothing but my VD, and this is a normal diode. So what I can do is that I can equate these two. So now what is my ID? My ID is the current flowing from this direction. So my current ID is nothing but this current plus this current. So what is ID? ID is the diode current. And what is the diode current? Diode current I0 into e to the power of Vd by Vt minus 1. And what is my IL? Minus IL. So what is my ID? ID is equal to, I will write it here, ID is equal to I naught into e to the power of Vd by Vt minus 1 minus IL. So this is the equation I will get for the for the solar cell. So now, by remembering this, now I will go to my characteristic. So what is my characteristic? So I want to utilize this region. Here this is the value of short circuit current and this is the value of open circuit voltage of my solar cell. Both are important parameters of my solar cell. So how can I get short circuit current? If I make my Vd equal to 0, then I will get ISC. How can I get VOC? That is open circuit voltage. I will get VOC, open circuit voltage, by making it ISC equal to 0. And I will get ISC by making my Vd equal to 0. అంతే కదా? ఈ పాయింట్ రావాలంటే నేను ఏం చేయాలి? ISC రావాలంటే ఈ లైన్ మీద Vd 0. VOC రావాలంటే ఈ లైన్ మీద I అనేది 0, ID 0, which is nothing but which will give the ISC. ID equal to 0. Here to get VOC, Vd should be equal to 0. Sorry, ISC should be equal to 0.
ID should be 0.
Now,
ID should be 0. VOC.
okay. ISC equal to 0. That means diode current should be 0. Okay. Now, if I want to find ISC, what I have to do? To get ISC, my Vd should be equal to 0. So, ID equal to I naught into e to the power of Vd by Vt minus 1 అనే ఈక్వేషన్ ఉంది కదా? దీంట్లో Vd equal to 0 అయితే I will get a current ID that will be nothing but ISC. That is nothing but ISC. So, when I will get ISC? When my Vd equal to 0. So, I will get a current. When my Vd is 0, I will get a special current. If my Vd is 1, I will get another current. If my Vd is 2, I will get another current. In the same way, if Vd equal to 0, I will get a current ID and that current is called ISC. And that current is called ISC. So what Vd is 0. So I naught
into 0
into 1 minus 1. Endukani e to the power of 0 will give 1. 0 will give 1. So what is my ID then? ID is nothing but ISC, which is nothing but minus IL. And then my ISC will be minus IL. First current. So what I will get? ISC as minus IL. Next thing. So if my ID is 0, so if ID is 0, I will get some value of voltage. And that voltage is called VOC. So let me write what will be my VOC. VOC into చూద్దాం. So to get VOC, what I have to do? First of all, to get Vd, what I have to do? First I have to make ID 0. So 0 is equal to I naught into e to the power of Vd by Vt minus 1 minus IL. అదే కదా నా ఈక్వేషన్లో వచ్చింది. సో IL is equal to I naught into e to the power of Vd by Vt minus 1. So IL by I naught plus 1 is equal to e to the power of Vd by Vt. So if I apply natural logarithm on both sides, ఎందుకని exponential power ఉంది కాబట్టి ln యూజ్ చేస్తాం. ln అంటే natural logarithm. If I apply natural logarithm on both sides, what I will get? I will get Vd by Vt. So what is my Vt? Vt into log IL by I naught plus 1, and this Vd is called as open circuit voltage, VOC. Is it clear? So how can I find my VOC? I can find my VOC by using this formula. And how I can find ISC? I can find ISC by finding the minus IL. So with this we can have these two values. Now if I want to find what is the efficiency of this device, ఇక్కడికి వచ్చేటప్పటికి దిస్ ఈస్ ద బేసిక్ సర్క్యూట్. ఒక రకంగా చెప్పాలంటే అంటే ఏంటి, మీకు ఫండమెంటల్ పరిచయం చేయటం కోసం ఆడింది. ఎఫిషియన్సీ తక్కువే ఉంటుంది, ఇంకా ఇంప్రూవ్మెంట్స్ ఉన్నాయి దీంట్లో. అవి సెపరేట్గా మీరు తర్వాత దాని మీద కనుక స్పెషలైజేషన్ చేయదలుచుకుంటే కనుక మిగతా సర్క్యూట్స్ అన్నీ కూడా అప్పుడు నేర్చుకోవచ్చు. మీకు ఇప్పటి వరకు మాత్రం ఇదే ఉంది. అయితే నా ఐ వాంట్ టు magnify this characteristic. So if I flip this characteristic, సరే ఇప్పుడు ఇది ఉంది కదా, ఇది క్యారెక్టరిస్టిక్ అని సపోజ్ ఇలా ఉంది, ఇది క్యారెక్టరిస్టిక్. నేను ఏం చేయదలుచుకున్నాను, ఇలా చేయదలుచుకున్నాను. ఫ్లిప్పింగ్ అంటే ఫోల్డ్ చేస్తాను క్యారెక్టరిస్టిక్. ఫోల్డ్ చేసినప్పుడు ఏమొస్తుంది, మై క్యారెక్టరిస్టిక్ విల్ బి లైక్ దిస్. ఇది ఇలాగే ఉంటుంది, ఇది మాత్రం పైకి వెళ్తుంది. సో ఆల్రెడీ వాట్ ఈస్ దిస్, నెగిటివ్ వాల్యూ. కరెంట్ విల్ బి నెగిటివ్, ఎందుకని రివర్స్ కరెంట్ కాదు, నెగిటివ్ వాల్యూ అయినా సరే ఐఎమ్ ఫ్లిప్పింగ్ దిస్ క్వాడ్రెంట్. అంతేగాని దాని వాల్యూ ఏం మార్చట్లేదు, నేను నెగిటివ్ని పాజిటివ్ చేయట్లేదు. అది ద కన్వీనియన్స్ సేక్ ఐఎమ్ ఫ్లిప్పింగ్. ఇప్పుడు ఏమవుతుంది, ఇది మైనస్ ఐఎస్సీనే, అంటే ఇది నెగిటివే, దీన్ని పైకి తీసుకెళ్ళా అంటే ఇది విఓసి పాజిటివే యాజ్ ఇట్ ఈస్. నా సో వాట్ ఈస్ ద ఏరియా ఆఫ్ దిస్ rectangle will be
ISC into VOC.
ISC into VOC. So I into V will give some power. Now if I want to, suppose I have my solar cell is operating somewhere at this point. My solar cell is operating at this voltage and at this current. My solar cell ISC is this much value and VOC is this much value. So what will be my solar cell power will be? Area under this line. Avuna? Now if my solar cell is operating at this point, so what will be area of this rectangle will be a less area. If somewhere on this curve my device is working and my device is at this point, So what will be the area of this region will be? It will be a maximum area. That means I have to see that my device will work the point at a point which will give the maximum power. Which will give the maximum power. So let us denote this point with a power which is Vm into Im. That means the voltage related to this point is VOC, which is nothing but Vm, the maximum voltage, and the current related to this point will be maximum current Im. So I will get a maximum power at this point. And we can observe one thing here. That means the maximum I can get with this curve is this area. And my solar cell cannot reach that. My solar cell cannot reach that. So the maximum area or maximum area can be covered with this point is this much only. So this is always less than this power. That means ISC VOC is always greater than IM VM. Isn't it? ISC VOC is always greater than IM and VM. And with this I can get a new parameter which is called fill factor. Which is called fill factor. Which is nothing but how much area will be filled in the largest area. Fill factor. So fill factor is nothing but ISC, IM VM divided by ISC VOC, which is always less than 1. Which is always less than 1. Now we are going to find what is the efficiency of my solar cell. What is the efficiency of my solar cell? Which is represented with eta, which is also known as conversion efficiency. Conversion efficiency. అంటే ఎంత ఎఫెక్టివ్గా లైట్ ఎనర్జీని ఎలక్ట్రిక్ ఎనర్జీగా కన్వర్ట్ చేస్తుంది అని. సో కన్వర్షన్ ఎఫిషియన్సీ ఈటా ఈజ్ ఈక్వల్ టు Vm Im by input light energy. Input light power. So if I replace this with fill factor, then what is my Im Vm will be? Fill factor into VOC ISC by P input. This will be my efficiency. So this is about the solar cell.